Hello, this is Matt from Matt Heaney Apps, and welcome to part 1 in our new 6-part full game tutorial series teaching you how to make a full iPhone game in Xcode using SpriteKit and Swift. In this series, we are going to make Solo Mission, a Space Invaders type game where you have to drag a ship left or right on a screen, firing bullets to kill enemies. In the game, you get a point for every enemy you kill, you lose a life for every enemy you let past, and it's instant game over if an enemy crashes into your ship. Over the next 6 videos, I will take you through every single step, teaching you how to make Solo Mission. In part 1 of this series, so in this very video, we will start making this game. And by the end of this video, you will have a ship moving left or right, firing a bullet in space. So, let's jump into Xcode to begin. So let's jump into Xcode, and we want to create a new Xcode project. We want an iOS application, which will be a game. Hit next. Here, we can name our game. So this game is called Solo Mission. Make sure here, the language is Swift, the game technology is SpriteKit, and the devices is universal. So our game will therefore work on both iPhone and on iPad. This game is supposed to be for iPhone, but the way that we will make this game, it will work on iPad without making any changes at all, so we might as well make this universal. And hit next. And save it somewhere nice and safe. So we have now created our Xcode project. However, before we can jump in and start making Solo Mission, we have to do a few things to set this project up in the right way. So to start with, here in this home area of Xcode, we will move down to the deployment info. To start with, we will find our deployment target and we will change this to 9.0. And this is iOS 9.0. And this here is the lowest iOS a device needs to be running in order to run your game. So as long as the device is running iOS 9 or above, it will be able to run Solo Mission. Also, whilst we're down here, we will find our device orientation, and this here will lock the device into a certain orientation, so either upright or on its side, so your game is played in the correct orientation. Now, Solo Mission will only work in portrait, so if you're holding your phone upright, so we will unselect landscape left and landscape right. You can select upside down if you want. That will work the exact same as portrait, just if the gamer turns their phone upside down. As this is a universal game, what we also have to do, just for a second, change devices here to iPad and do the same for iPad. And then jump back to universal. As the iPad now doesn't support all 4 orientations, so portrait, upside down, landscape left and landscape right, we now have to select requires full screen. So we've now said only run this game on iOS 9 or above. Lock this game into portrait or upside down, so that's holding your phone upright, not on its side. And because we have done that, we need to select requires full screen. So our project prep is coming along nicely. Before we can jump in and do any coding, however, we need some assets for this game. It needs some images, and over the course of this series, we'll be using images, sound effects, backing audio, and a custom font. But for right now, we're only going to worry about the images. So we will import the images that we need for Solo Mission into this project. So what we're going to do is over here on the left, we will find our assets folder. And in here, we will import all of the images that we need for this game. Now at the moment, we have a space for an app icon, and we have a spaceship that Apple gives us as part of their Hello World code, which we don't want. We have our own spaceship, so we will select spaceship and hit delete. Now in here, we will import all of our images. So my images are here on my desktop, and there is a link down in the video description where you guys can get your hands on these images. So what we're going to do is highlight our 5 images, our background, our bullet, our enemy ship, our explosion, and our player ship, and then just drag it into the assets folder. Okay, so we now have a background. You can't really see it here, but it's a starry sky background. We have a bullet, we have an enemy ship pointing to the right, and there is a reason why this is pointing to the right. which I will explain when we use it in part 2. We have an explosion image, and we have the player ship. So the ship that the player is going to control. So we now have all of the images that we now need for this game. Okay, so we now have one thing left to do before our project is fully prepared and ready to go. Now, as you may have noticed, we only have one set of images. We only have one player ship, we only have one background, one enemy ship, one explosion, and one bullet. And this is a universal game, meaning this game is going to work on every iOS device, from the small iPhones, the 3.5 inches, all the way up to the iPad Pro, and anything in between, or bigger and smaller, if in the future they release a phone smaller or an iPad bigger. And now one way to get this game to work on all of these different devices is to have lots of sets of images. So you'll have a set of images for the smaller iPhones, the bigger iPhones, the iPad mini, the iPad Pro, and so on. So basically you'd end up with lots of different images of the player ship, for example, all in different sizes to work on all these different devices. However, this can make your images a little bit tricky to get your head around when you're starting out. And if you're kind of working on a budget for the App Store, getting all of those images made is not always possible. Trust me, I've tried. Graphic designers will end up hating you. So instead of setting our project up in a way so we have all of these images, what we will do instead is use a technique that quite a lot of simple games use, which I think is really good to use when you're starting out in SpriteKit, just because it makes things a lot simpler. So what we're going to do is eliminate that problem entirely. Instead of treating every device as a different device size, we are going to hard code a size for our game to work on. So we're going to give our scene a set size, and it will then just scale this scene to work on every device. So instead of making some changes for the smaller iPhones, the bigger iPhones, iPad mini, iPad Pro, and so on, instead we're going to make one game fit one size, and then this will simply scale onto every device. Then we can have one set of images, and we still get the same universal effect. It's simple, and I think pretty effective. This set scene size is going to be pretty big, so no need to worry about pixelation. To set this up, we will jump into our gameViewController, and we will find our view did load. Now the gameViewController is presenting us a scene. When we see a scene, whether it's the game scene, a scene for the main menu, a scene for game over, for options, for credits, a scene for whatever, all that's really happening is that scene is being presented in this view controller. At the moment, what this is saying is take the game scene and present it. Scene equals game scene, prepped it a little bit, and then presented scene, which is the game scene. Here is where we can use our technique. So what we're going to do is find this line, and for now, entirely delete it. And because we deleted an open curly bracket, we will delete one closing curly bracket. And for this technique to work, we are going to replace that line that we just deleted, and we will say let scene equals the game scene. So we will still be taken straight into the game scene, but this time we want to set a size. So size colon, and to do this we will set up a CG size because we can now put in a width and a height. Now when using this technique, the standard is to use a width of 1536 and a height of 2048 when you're using portrait mode. Need one more bracket at the end just there, and this size here can scale onto any device. So now with just this one line we have our simple technique to make our game universal in one set size so we can use one set of images. It will now scale the scene for us to fit any device. And with that, our project is now fully set up and ready to go. So as we just said, straight away, we will now be taken into our game scene. So let's jump over into our game scene to start making our game. So we'll find our gamescene.swift over here on the left. And at the moment, we have all of this code here, which is a Hello World app that Apple made for us. So we don't want any of that. So what we would do is empty out this scene entirely. So all we are left with is this, a blank game scene. So now that we have a nice blank game scene ready to play with, we can now start making our game. So the first thing that we're going to do is create a background and our player ship, the spaceship that the player is going to control. Now we want these to be on the scene straight away, so we will set up our did move to view function. And this function here is going to run as soon as the scene loads up. So anything we have in this block here, so between this bracket and this bracket, is going to happen straight away. And therefore, if we make our background and our player ship here, it'll be on the scene and therefore on the screen straight away. So let's begin with our background. We will say let to declare something new, and we will call this background. This is going to be an SK sprite node, which is an image. So a sprite node, an image object, an image. And what we have to do here is say which image we want this sprite node to be. So what image is going to be background? Over in our assets folder, the image that we want to use is background. So we're going to say image named, and then in the speech marks we will say background, exactly as it is in our assets folder. Now, as all of these images have been made in the correct size for this game, we haven't got to set a size for these images, because by default, if you don't set a size, the image size is carried over into your game, but we're going to include it anyway just so you can see how it works. So for the size of this background image, we want it to match the size of the scene, because it has to cover the entire scene because it's a background. To do that, what we're going to do is take background, this name from up here, and we will set the size. So dot size equals, and now we could give it a width and a height, it's what it needs for a size, but as we want this to match the size of the scene, we can say self, which is representing the scene because we're in the scene, dot size. Okay, so take the background and set the size to be the same size as the scene. We now want to give this background a position, so background, again this name from here, dot position equals, and for a position our background needs an X coordinate and a Y coordinate. So X is where this would be across the screen, Y will be where this is up and down the screen. So position, we're going to use a CG point to easily put in an X and a Y value. And because this position relates to the center point of our background image, we want this to match the center point of the scene. So it covers the entire scene because it's a background. So to do this, for the X, what we're going to do is take the scene, take the size of the scene, take the width, and divide it by 2. So find out how wide our scene is, divide it by 2 to get the center point going across, and set that value to the X. For the Y, same sort of thing, but for the height. So figure out how high the scene is, divide it by 2 to get the center point going up the scene. So we now have the center point of the scene set to be the position of the background. The X is set to the halfway point going across. The Y is set to the halfway point going up the scene. So now we have that center point. What we also have to do is give this a Z position, which is to do with the layering of objects. As this is the background, we want this to be at the bottom of our game, so the furthest back. Because if it was in front of other objects, you wouldn't be able to see them. Imagine if you're looking down at your game, you put the player ship on first and then put the background on the scene on top of it, you wouldn't be able to see your ship. So the Z position is the layering. The lower the number, the further back. So we'll give this a Z position of 0. And then all we have to do is take all of this information and actually make our background. So we'll say self, and to actually make something, we will say add child background. So take all of this and make it. So we now have a background, we now need a player. So still in the did move to view, we will say let, we'll call this player. Again, it's going to be an SK sprite node, and the image this will use is going to be player ship. So this one just here. So image named player ship. Now again, this was made in the correct size, so we haven't got to set a size. What we will do, however, is put a line of code in so you guys can have some more freedom around how this game looks. So when we say player.setScale, and we just set this to 1. So a scale of 1 is just normal size. But if you want this ship to be bigger, increase this number to 1.5 to 2. If you want it to be smaller, lower this number. Okay, so this will set the scale. 1 being normal size, 2 being double the size, 0 being impossibly small. So I will just set it to 1. It's in the right size that I want, so that will just keep it at normal size. We've got to give this a position. So player.position, so affects the position of the player. Again, a CG point for this X and the Y. And this will start halfway across the scene. So grab the width of the scene, divide it by 2. For the height, however, we want our player to start 20% of the way up the screen. So self.size.height to get that height of the scene. And then we could divide it by 5 to get 20%, or times it by 0.2. We have to give this a Z position for the layering. Now, as long as this is above 0, it will be on top of the background. So we could put 1. However, we will put 2, because later on, when we fire a bullet, we want the bullet to start underneath the ship. So that will have a Z position of 1. Okay, so set this to 2. Then all we got to do is add our player. So take all of this and actually make it. So we now have a background and a player. Our player is using the image that we want. It has a scale of 1, so it's just normal size. But I put that in there in case you guys want to do a bit of customization. It has a position halfway across the scene, 20% up, and a Z position of 2, so it's always in front of the background, but there's room for a bullet underneath it. So now that we have our background and our player, we are going to test this out. So what we're going to do is come up here to the top left hand corner. We will select a simulator or an actual device, and we will hit run. When we hit run, as soon as our game loads up and after the loading screen, we are going to see our background and our player straight away because they're in the did move to view. So let's check it out. So here is our game so far. As you can see, we have our background and we have our player spaceship. Doesn't really do much yet. So we will now make our spaceship do something. Okay, so back into Xcode. The first thing that we will make our spaceship do is fire a bullet. So what we're going to do, after our did move to view, we're going to make some room and we're going to make a brand new function which will spawn and fire a bullet. And then all we will have to do when we want to fire a bullet is call this function. So we're going to say func, and we will call this fire bullet. We won't pass this anything. With an open curly bracket, drop a line. It should put in your closing curly bracket for you, but if it doesn't, put that in now. So for this bullet, what we are going to do is we are going to make a brand new sprite node, move it off the top of the screen, and then delete it. So one step at a time. Let's begin by spawning a bullet. So we will say let, and we will call this bullet. It's going to equal an SK sprite node. And the image that we're going to use for this will be bullet. So bullet. Again, this has been made in the right size, so we're not going to set a size, but we'll throw a set scale line on there in case you want this bullet to be bigger or smaller. Mine's going to be 1 because I think it's the right size as it is. Okay, so without a size, it will just use the image size in the game. Okay, so we now want to set a position. So bullet.position equals. So where do we want to position this bullet? We want it to look like the bullet is being fired out of the ship. Okay, so we could, in theory, use the same position as the player. This up here. Halfway across the screen, 20% of the way up. And for now, that would work. But later on in this video, we will be moving the player ship left and right. And if we move the ship left, for example, and then fired the bullet and it spawned at this point here, it's going to look really weird because it kind of won't be lined up with the player. So we don't really know where this will fire from. All we know is that we want it to match the position of the player. So wherever the player is, spawn the bullet there to make it look like the bullet has been fired out of the ship. So we want to get access to player. However, at the moment, we can't do that. Because we declared it within this function and this block of code here, if we try to get access to the player's position, it's going to kick off because it doesn't know what player is. And that's because we declared it within this other function. Thankfully, there's a pretty easy workaround. Because we only want one player, what we can do is change where we declare this to be outside of any functions. So now we can affect it and gain access to it all over the scene. So we can now set player up in the did move to view, but still access it in fire bullet. So now bullet has a starting position of wherever the player is. We've got to give it a Z position of 1, so it's in front of the background, but still behind the player, so it looks like it's being fired from the bottom. And then add the bullet. So now when we run this function, a bullet will spawn. That's pretty cool, but it will just sit there. It won't do anything. So we want this bullet to do something. We want it to move up the screen and then be deleted once it's off the screen. And to do that, we will use actions. So still in fire bullet, we will say let to declare something new, and this will be an action, which will make our bullet do something. And we're going to call this move bullet. It's going to equal an SK action. And this action is going to be move to Y. So we're going to move to a certain Y coordinate. Okay, so we're going to move to a certain point off the top of the screen. And the point that we want to move to is the top of the scene, so self.size.height, and we're going to add bullet.size.height. So the total height that this bullet is going to go to is how high the scene is, plus the size of the bullet to make sure it's entirely off the screen, with a duration of 1, so move there in 1 second. We also need an action to delete the bullet once it's reached that point, otherwise it will move and then stay there, and then sooner or later we're going to have a lot of bullets off the screen and that will lag the game really quickly. So delete bullet equals SK action dot remove from parent. So if we run this action, it will delete the bullet. So we want to run both of these, but we want to run it in an order. So we want to move the bullet entirely. We want to completely run all of this action so the bullet will reach this point before we run this action to delete it. And to do that, we will use a sequence. Now a sequence is a list of actions that will run in order one after the other. So it will move, and then when that has finished, we will delete it. So we call this bullet sequence in SK action dot sequence, and this here is going to ask us for a list or an array of actions in order that we want them to run. So we need square brackets because it is an array, and then we can simply list these actions. So move bullet, so do this first, and then once that's finished, delete it, so do this. So we then will take our bullet and tell it to do this sequence by saying run action bullet sequence. So take our bullet and do this. So move and then delete. We will add to this in just 1 second, but first I want to test this out. I want to spawn a bullet and make it fire. Now in solo mission, to fire a bullet, all you have to do is tap anywhere on the screen. So what we're going to do is set up our touches began function. Make sure you're outside of any other function, and this function here is going to run whenever you tap on the screen. So all we have to do is say run fire bullet, so call fire bullet. It will then come to this and do all of this. So now when we touch the screen, fire a bullet. So let's test this out. Hit run. So here is our game so far. Now when we tap on the screen, we fire a bullet. So our shooting system is now almost in place, but it's sort of just missing a little something. What we want to do is add a sound effect to this. So when we fire a bullet, we are going to play that sound effect. So let's jump back into Xcode. So to add a sound effect, the first thing that we need is a sound effect. So the one that I'm going to use is here on my desktop. However, I bought this sound effect to use in this game and in this tutorial series, so I don't own this. So I can't give you this sound effect. And that's the same for all sound in this tutorial and probably in all tutorials, because to be honest with you, free sounds are horrendous. So yeah. So what I'll do, I'll use this sound effect. I'll put a link down in the video description for if you want to get your hands on this sound effect. It only costs like a few dollars. If not, you can replace this with your own sound effect or a free sound effect, or you haven't got to put a sound effect in at all. Entirely up to you. So I'm going to drag my sound effect into my Xcode project over here on the left, making sure copy items if needed is ticked, because this will make a copy of the sound effect in your projects folder. Hit finish, and we now have our sound effect in our project. So a sound effect is just another action that we're going to add to our bullet sequence. However, if we just set this action up here, just like these two, the first time you play the sound effect, there's always just a little bit of lag. And that's always really annoying. And you obviously want to avoid that. So instead of saying let here and doing it all here, what we're going to do is declare this globally within the scene. So outside of any functions, just like our player, we will declare this globally and then simply run it. That way we won't get any lag. So we'll say let bullet sound is going to equal an sk action dot play sound file named. So here we're going to say what sound effect we want to play. So mine is called bullet sound effect dot wav. So bullet sound effect .wav. Wait for completion will set to false, and I'll explain why in just 1 second. So back to our fire bullet function and back to our sequence. The first thing that we're going to do is run our new action, bullet sound. So now this is the first one in our sequence. So when we fire the bullet, the sound effect is going to play, then it will move, and then it will delete. That is why setting wait for completion for this action to false was so important. Because now it's false, what we're saying is start playing that sound effect and then straight away move on to the next action. Okay, if we set wait for completion to true, the entire bullet sound would play, and then once it's finished, it would then move. But we don't want that. We want it to start playing and then straight away start moving. So that is why that was false. So now, when we fire a bullet, we have a sound effect. Let's check it out. So now in our game, when we fire a bullet, we get a sound effect. Later in this series, we will also have explosion sound effects and backing audio. So they'll all kind of work together. So I mean, that's pretty cool. What we will now do to finish this video is make our player move left and right. So let's jump back into Xcode. Okay, so let's get our player moving left and right. The control system in solo mission is the gamer can drag their finger anywhere on the screen, and the ship is going to move the same amount left or right that the player has moved their finger. Okay, so they haven't got to be touching the ship, they can drag anywhere and the ship is going to mirror this movement. So if you drag a little bit to the left, in the center of the screen, the ship is going to move the same amount left. Okay, to set this up, we are going to use our touches moved function. And this is going to run whenever we move our finger around the screen. So when our code picks up that our finger has moved, this will run. So what we're going to do is we want to figure out where we're touching the screen right now. We want to figure out where we were touching the screen. We then want to use those to figure out how much we've moved our finger left or right. And then we want to affect the player's position in the same way. Okay, so one step at a time. To start with, we want to get all that information about where we're touching the screen now and all that information about where we were touching the screen. So in the touches moved, we will say for touch any object in touches. Okay, so with this, we can now use touch to break down all the information about our touch on the screen to get all this information. So the first one we care about is where we're touching the screen right now. So we're going to say let point of touch, so declare something new with a name of point of touch, and it's going to be equal to the coordinates of where we're touching the screen right now. So this will be equal to touch, this from up here, touch dot, and to find where we're touching right now, it'll be dot location in node of self. So what's the location that we're touching in the scene? Where are we touching in the scene? Okay, so that is where we're touching right now, but we also care about where we were touching before it picked up that we moved our finger. Because this function is going to run if it picks up the smallest movement. So if you drag your finger across the screen, it's actually going to run a lot of times. Okay, so this one's going to be called let previous point of touch. I'm going to set this to where we were touching. So touch, again, this from up here, dot previous location in node of self. So where were we touching in the scene? And with those, we can now figure out how much we have dragged left or right. So let amount dragged equals, and to figure this out, we are going to take point of touch, so where we're touching now, and take the x coordinate and take away previous point of touch dot x. So find the two x coordinates of where we're touching now and where we were touching. So find how far across the screen we're touching now and how far across the screen we were touching, and figure out the difference. So how big of a gap is it between where we were touching and where we're touching now? So what we then have to do is take this gap and affect the player in the same way. So player.position.x. And we want to affect this by adding amount dragged. So if the player's x coordinate is 100 and the difference is 10, we want to go to 110. So we want to add to this. If the difference is minus 10, we're going to add minus 10, which will then take 10 away to go to the left. So we're going to say plus equals, to add to this value, amount dragged. So figure out where we're touching now and where we were touching. Figure out the difference between those 2 points across the screen, and then move the player ship left or right in the same amount. And just with that, we now have a control system in place. We can drag anywhere on the screen, and the player ship will be affected going left and right in the same way. So let's check that out. So now here is our game. We can still tap to fire, but now if we drag left or right, we can move our ship across the screen. So that's looking pretty cool. However, at the moment, we can just drag our ship straight off the edge of the screen. But don't worry, we're going to fix that problem in video 2. So we've now started to make solo mission. We have our ship going left or right, and we can fire a bullet. In the next video, we're going to limit how far we can drag our ship so it stays fully on the screen, and we will start spawning some enemies. So by the end of the next video, your game will look like this. But for today, that is all. Thank you very much for watching. If you liked watching this video, which I really hope you did, make sure to hit that like button, hit subscribe, and I will see you next time. Goodbye.